Okay, so let's go ahead and continue in this part 2. We're gonna basically leave this function up here as it is. As I have stated, we're just gonna remove the throw from here, and now we're gonna go ahead and venture into the main. So double num, again we shall need it, and oh god, I'm gonna need to do this. Wait, is there like... Oh yes, Control Z. Blessed be Control Z. Okay, going back. Going back with Control Z. I'm just pressing Control Z. Set. Control set. There we go. Is that it? Enter. Oh my god, yes, it is. Fantastic. So just, again, remove this. And I need you to have this on your screen, this code basically. If you cannot go here with Control set, just pause the video and then type it in. Anyway, all this is here as it is, and now we're gonna just give me a second. My notes. No, not there. Yep, there we go. So anyway, sorry, my notes like ran away from me completely. They don't want anything to do with me anymore. So we have double square root and then equals something. Okay, so let's remove this initialization from here. Press enter, enter, and let's go ahead and start typing. Oh, yep, there we go. No need to remove anything else. Type in try. Enter. Open up the curly brackets. And this time we shall use square root, but inside the try block. So this will be equal to sqrt capital S, remember that, num. So it will try to call the function and pass the argument num, depending on what the user entered. So it might be a positive, a negative number, or whatever that's going to get passed to the function. And down below, we shall have catch. And catch shall be const char pointer text. Just take this as is for the time being. So the exception is basically of type const char, which is why we basically catch it here. So let's go ahead and do this. And well, we have already determined the exception type when we wrote throw negative number. And the text negative number is basically of type const char. That is what we wrote before. But here we will basically catch the exception. What we are going to do is just write the error to the screen. So we're going to warn the user or something like that. I'm not gonna use the formats that I've given you down below. So we're gonna have catch, and then we're just gonna write std : cout. I don't know, error. We could basically write whatever we wanted here, and this is gonna like go text std : and l. Okay, no worries. We still haven't like defined the text, but we're gonna get to that. Anyway, this is going to, and we're gonna have down below the printout of the result. So let's see how this works. But wait, we need return 1, and here we go. So I mean, we have defined, you have text here, so there is a pointer. Sorry about that. Just go ahead and run it. Okay, so there is an error. There is a problem. What did I miss? Let's go ahead and take a look. So chat. It's not chat, it's char. There we go. Okay, enter a number. Let's go ahead and enter a negative number straight away. So -10. -10 equals sqrt. -10 equals nan. In case we run this program and enter like well, in my notes it's -9, I have typed in -10 here, we will basically get these outputs. So we're supposed to get something under the error, but no. Unfortunately, this is happening. This is like error negative. We should get error negative number. Why? What is the problem? Where does our problem lie? Think about it. What have I deleted here in this whole program that's missing now? What is one thing that makes sense? What is that thing that needs to be passed to the catch block? Huh? Think about it. We're missing the throw statement. We're missing the throw, the one that I have deleted pretty much deliberately, and that is something that is going to get caught here. So it doesn't make sense to actually catch something that is not thrown. How can you catch something that's not thrown when there is nothing to catch? So all we need to basically do is, no big deal, just return to the previous code, and I don't know, go to the function right here, and just type in what we've typed in before. Nothing special. So if x is lesser than 0, we'll just throw negative number. There you go. So we're going to catch this. This is what we are interested in. So you need to throw it in order to catch it. The function throws it. If this fails, exception is thrown, and catch will catch it. The catch block will catch it. So let's build and run one more time. -9. What do we have here? It says error, negative number. What on earth are you doing? The program is saying, dude, you can't enter a negative number here. And that pretty much sums it up. I know it's been quite a journey to get here, but oh well. Now, this is just the beginning. There's more. So, there are like a lot of things which you can do with try and catch. The try and catch blocks, they're usually not this short. They are a lot longer. So, let's go ahead and have a look. Basically, let me just go ahead and include one more library here. It's going to be include std std accept. Yep, there we go. So std accept for standard defined exceptions. So standard defined exceptions are here. So why are we doing this? Well, because I want to show you that one try can have many catch blocks. In fact, you can have pretty much as many as you would want. So we no need to actually delete this function. It can stay there. We can just not call it, and it will not run. So void. We shall create another function for this purpose. I don't know, let's just leave it and call it something. Something, because I'm running out of names. These functions, and we're just gonna have one integer there. And now it's getting complicated. I should probably just leave the. Now I'm not gonna go against myself, to be honest. If there's more than one, it's supposed to be prototyped, but well, it's not. There aren't any specific rules that are stating it to be so. It's just me and my imagination. Anyway. If I create this in the following fashion, so if n equal to 0, throw 1. So we're throwing an exception that's basically, we're throwing an integer. If n is greater than 0 and n is lesser than 100, so n is somewhere between 0 and 100, 0 and 100 not included, throw, it really doesn't matter, blah blah blah, tra la 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 la. Of course, you would write something meaningful here so that you would later on know what the problem is. You wouldn't write blah, 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 tra la la la, or randomly smash your keyboard. So yeah, but you need to be careful of these types. So this is an integer. This is basically a constant char pointer. And down below, we're gonna go ahead and have like if. Because each one of these will need to have a catch block of its own, and each one of these will have a type that it will catch, so to say. If it's -1, again, we have an, we're gonna, I don't know, throw, I don't know, some character. Let's say C. Let's throw character C. So this is basically a character. And if down below we shall have n is lesser than -1, throw domain error. Now, domain error is a standard exception. std : domain error. Okay, some std exception. There we go. Perfect. So you have a good list of exceptions that are thrown in this function. Of course, this function is pretty much only for demonstrative purposes. Usually it wouldn't be like this, but oh well. I just wanted to show it to you how it actually works. So down below, we are going to go ahead and create ourselves an entire series of catch statements. So let's go ahead and begin from this one. So let's go ahead and modify this one to char C. So I don't know, some character, just a type C. So it just catches a char. And we're going to delete this return statement from here. And let's go ahead and delete the error. And I don't know, shall we name this? So caught char. So caught a character exception. I don't know, whatever. Doesn't really matter. You can type there whatever you want. That's just purely for your own convenience. And of course we won't need this. It's purely for your own convenience, as I said. There aren't any specific rules which bind you to it. Int I. And we're gonna go ahead and type in std : cout caught int std and l. We're just gonna have like two more. One will be for the constant char and the other one will be for the domain error. Char pointer dxt. It's gonna be std cout caught text dxt std and l. Okay. Catch std : domain error, I don't know, de. So catch the domain error. We're just creating different catch blocks for different types. So std, and it's very likely that you will have different types of, I mean, the throw can pretty much throw anything. So they need to be prepared. Caught the main error with text. Okay. We're gonna write this de dot what. It's gonna be like this. That should be all. And down below, we will of course delete this line and you will have return 0. Okay, so let's run it. Let's run and see what happens. An error happens, of course, because of my brilliant programming, SQRT was not defined in this scope. Okay, right. Something and num shall be int, and we will no longer require this here. Go. Seriously? Oh, okay. I understand. I gotcha. What now? What now? Ah. Error. Exception before std. Oh, right. There we go. Ups running. So, what did we say? Let's go ahead and scroll upwards. If it's equal to 0, throw 1. Okay, 0. Caught int. Okay, that's fantastic. What else you got? If it's between 0 and 100, 0 and 100 not included, let's say 88. Caught text, blah, 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 tra-la-la. You see it here? There we go. Okay, so let's run it a few more times and see what happens. If it's -1, it says caught char. And the last one would be actually if it's a lesser than -1, which is like, I don't know, -3. Caught domain error with text, some std exception. And as you can see, we have it right here. It's written. So you see, you can throw all sorts of exceptions, and then you can catch them down below, and you can see just how many of these catch blocks can there be. There can be a lot of them. Like, you can have multiple try catch blocks on end. Especially useful, these try and catch blocks are especially useful when attempting remote connections. For example, if you have a program, some sort of a desktop application or whatever, it doesn't really matter, as long as it's written in C++. And it doesn't actually necessarily need to be written in C++, it can be written in a good number of languages in this fashion. So let's say you're trying to connect your program to a database or to a server somewhere. Whatever server. Maybe you're trying to establish an SSH connection. Maybe you are trying to go to the FTP servers, something. It doesn't matter as long as it's some sort of a connection. And if you're trying, for example, to connect to a database, you know, connections don't always work, you know, regardless of whether you have internet connectivity or not. So the program will attempt to connect, and you need a try and catch block. Okay, try to connect, fail. And if you fail, don't like shut the program off, like just fail and throw an exception or try again in a certain amount of time and keep trying. And if you try 10 times, for example, okay, throw an exception of some sort. Well, not even like that. Try 10 times, okay, in certain time intervals, and then start running some sort of diagnostics. Check whether you can ping, check whether you have internet connectivity, check if the port is open, check if you have proper permissions, etc. So for example, if you try to ping a site that you know that you can ping, and if that fails, you can throw an exception, no connection. Or you can configure your program to check your IP settings. So you can say like, hey, you don't have an assigned IP. Or, I don't know, your DNS settings are wrong. So you can throw such exceptions, and then the developer can look at them, or whoever the user is can look at them and figure out what the problem is, so they can solve it themselves. Anyway, this brings an end to this first section of this chapter, and I'm sorry that I've kept it so long. I really am. I know that it's long. I know that this was a bit long, but I needed to show it to you. This is a very important part of C++, and you will use these things pretty much all the time. Anyway, bid you farewell, and I shall see you in the follow-up tutorial.